This is not just another clock. It's something smarter. Meet PixelFrame, a DIY smart clock built with ESP8266, a vivid ST7789 display, and the ultra-precise DS3231 Real-Time Clock. But PixelFrame is more than just telling time. You can customize it with colorful wallpapers that bring your clock to life. And control everything wirelessly, straight from your phone or computer. So let's build PixelFrame that blends creativity into one smart DIY clock. Meet the Wemos D1 Mini, built on the ESP8266. This tiny microcontroller comes with built-in Wi-Fi, making it the perfect brain for IoT and DIY projects. Simple, affordable, and versatile. Perfect for DIY projects. ST7789 is a vibrant 240 by 240 pixel TFT display that brings your projects to life in full color. With sharp graphics and a compact size, it's perfect for clocks, dashboards, and creative DIY builds. The DS3231 is a highly accurate real-time clock module. With its built-in crystal and temperature compensation, it keeps time perfectly, even when your project is powered off. And here is the simple wiring diagram of the PixelFrame project. Really simple, isn't it? So let's go ahead and build this awesome project. Take Wemos D1 Mini and install it on the breadboard. Take the display and install it on the breadboard. Take RTC module and install it on the breadboard. Take red jumper wire and connect one end to 3.3 volt pin of the D1 Mini and other end to VCC pin of the display. Connect ground pin of the D1 Mini to ground pin of the display. Connect VCC pin of the display to the VCC pin of the RTC module. Similarly, connect ground pin of the display to ground pin of the RTC module. Reason of doing this because both components runs on a 3.3 volt. Now take green jumper wire and connect SDA pin of the RTC module to D3 pin of the D1 Mini, and connect SCL pin of the RTC module to D4 pin of the D1 Mini. So connection to RTC module is completed. Now take orange jumper wire and connect SCL pin of the display to D5 pin of the D1 Mini. Now take green jumper wire and connect SDA pin of the display to D7 pin of the D1 Mini. Now take yellow jumper wire and connect reset pin of the display to D0 pin of the D1 Mini. And finally take gray jumper wire and connect DC pin of the display to D1 pin of the D1 Mini. And finally, our connections to both components are completed and we are ready to move further. Let's move on to the Arduino IDE and see the sketch. Connect D1 Mini to the PC and open IDE. This is the main PixelFrame sketch, the brain of our project. At the top, we include all the essential libraries. Wi-Fi for wireless control, LittleFS for file storage, TFT ESPI for the display, Wire and RTC lib for the DS3231 Real-Time Clock, and a sync web server with JSO handling to manage the web interface. We also include the logo file for the startup splash. Next, we initialize the ST7789 display, the DS3231 RTC, and set up the web server and WebSocket communication. The sketch defines constants for the display size, wallpaper slots, and a settings file that stores user preferences like clock color, position, and 12 or 24-hour format. In the setup function, we mount LittleFS, initialize the display, show a pulsing heart and logo splash, then connect to the RTC. If the RTC has lost power, it automatically resets to the compile time. We then load settings, start the access point, and configure the web server. If a wallpaper exists, it is drawn to the screen. Otherwise, a default no wallpaper message is shown. Finally, we draw the clock overlay. The loop is simple. It cleans up WebSocket clients and updates the clock overlay every second. Supporting functions handle reading and writing settings, drawing wallpapers, restoring the background behind the clock text, and rendering the time and date in the chosen position and color. Web server routes allow uploading and managing wallpapers, syncing the RTC from a phone or computer, and updating settings live. Together, this sketch combines hardware control, file storage, and a responsive web interface, making PixelFrame a customizable smart clock. And with this, we are ready to upload sketch to the Wemos D1 Mini. Select the board and hit upload button. Check I button to learn how to upload data folder files to flash memory. As soon as PixelFrame powers on, it greets you with a playful pulsing heart, a little sign of the love behind this project. Right after, the brand logo takes center stage, giving the clock a polished, professional touch. Once the setup is complete, the real magic begins. The date and time appear clearly on the display, and with just a tap from the web interface, we can move them around the screen, top left, bottom right, or even perfectly centered. Next, we explore the wallpapers. With a single click, PixelFrame switches backgrounds smoothly, one after another, turning a simple clock into a colorful frame. To make it truly yours, you can even change the font color, from crisp white to any shade you like. And finally, here's a wide view of the complete setup. Clean, compact, and fully wireless, PixelFrame combines style and function in a way that's simple to build, but exciting to use every day. Crop and resize your favorite image to 240 by 240 pixels, and as shown here, select the settings as per instructions and download .bin file and rename it to .raw file. Simply upload it to your PixelFrame and see the magic. The PixelFrame portal makes customization simple and wireless. You can choose the clock's position, switch time format, change the font color instantly. The gallery section lets you manage wallpapers, and with the sync option, the clock's time can be updated instantly. And that's PixelFrame in action. If you enjoyed this project, don't forget to like, share, and subscribe to the channel. Till then, I am DHK signing off.